This is the dashboard of memodya. Here you can manage several memo files. For example, here we have the featured spaces where the memo files are filtered according, for example, if they are pinned or last modified or where you have the responsibility. And then we have spaces. Here in spaces, for example, you can manage all your memo files. A memo file is at the end a file which contains a set of methods we are modeling in the next few minutes. And this file, let's say, contains all these methods. And for example, you can use one of these files for one of your projects. But you can also organize it in a different way. So for example, when we go here to the default space, at the moment this default space is empty. So let's create a new memo file. Here we click on new memo, then a new file is created. Here we see the file name and also subname and the status. We can assign a responsible person. At the moment it is myself because I am the author of this file. We can add relevant links, for example, to some specifications or whatever. And yeah, we can bookmark it, for example, then it is also here in the pinned folder, in the pinned featured space. Then let's go back. We can also share it with other users. At the moment I'm sharing it with myself, but here I can invite others. I can specify the access rights, for example, read only or can edit. And here in the default space or in the space section, I can also create further spaces. So for example, I can create some spaces where I can organize all my memo files. So for example, here in this space at the moment it is empty. Of course, I can rename it, I can delete it, or I can move it, let's say, up and down. And then, for example, when I want that this memo file here is in this space, maybe let's rename it. Let's call it demo space. And here, just simply via drag and drop, I insert it here, and then it is also here. So this default space acts as a kind of single source of truth where always all memo files are located, and in these spaces it's a kind of organization where you can manage your memo files individually. Okay, then also we have a list view, for example, when there are several files, but also the card view. But now really let's go to the heart, let's open the editor. For this we select the memo file, in this example this only file here we have created. For example, when we change to edit mode, we can also change this demo memo, and then let's open the editor. Here in the editor we can now create our methods and all the inputs and outputs for the methods, and we can link them. So let's start. Here on the top left we have the method. Just via drag and drop we bring it on the diagram, in the diagram. Then we have here the new method. Let's say, for example, this is the requirements engineering method, requirements definition method. We can also, for example, insert here a short description of our method, and then we can start off specifying this method, because this requirements engineering definition method, for example, creates one output. This is in our case the requirements model. And maybe let's make it a little bit more complicated. Let's say these are system requirements, because then we can use several methods. So we have here the system requirements model. And as input, for example, we need, let's say, some stakeholder needs. And let's say also we have available from somewhere use cases. Done. So let's keep this simple for the moment. And now, okay, we have our inputs, our outputs, we have the method, and now we need a description of the methods in terms of which steps are performed. And for that, we add here in this section steps, a step. For example, the first step for our requirements engineering method is to consider or to analyze all the inputs. can detail this here with a short description. For example, check stakeholder, not the stake, the stakeholder needs in terms or needs with focus on deriving requirements in parallel to analyze the use cases. Okay, then for example we can add another step. So in this way, let's say we prioritize all the requirements, or based on the inputs we have to derive requirements first, so to check which requirements with based on the inputs which are relevant, which are not. So here we derive some requirements. Also here we can of course add a description. We can also assign an input or an output if we want. Then we can, for example, add a further step. In this case, let's say analyze requirements. Then we can add another step, for example, specify requirements. And we can add another step, for example, with review and release requirements. Of course, it is best practice also to insert here a description of each step, but let's keep it short for the moment. And yeah, that's our requirements, our system requirements definition method. And now the interesting part begins, because now we have one method, and we know typically for development approaches it's not only this one method, we have a set of methods. So let's continue, let's insert another method, and let's call this method the system architecture method. Here, for example, one of several inputs is or are the system requirements. Then of course we can have some benchmark reports from other systems, benchmark report, and of course we can have many other things. So for example, let's say we have already requirements modeled from a previous project. So let's say reference requirements. And the outcome in this case is, for example, on one hand our system architecture model. And also, let's say we want a specification of the architecture in form of a document, system architecture specification. We can also, for example, split this method in two methods. So for example, let's say we have the first part of the method creates the system architecture model, and based on the system architecture model we derive the system architecture specification. That's also possible, but here, for example, let's keep it short. Then next step is, when we have done this, we need to go to the subsystems. So let's say we have another method, which for example is the EE, the electric architecture method. For this, for example, of course, we need the system architecture model as one of several inputs, and of course, as we have it already here, we need some requirements, for example. Let's say on one hand we want to have as direct input our system requirements model, because we just want to have it as an input, but also we know that there are some specific requirements for our EE architecture. So let's say we have here another method we call the EE requirements definition method. Oops. And here, of course, one input is the system requirements model. As output, we have the EE architecture model, the EE requirements model. And this is of course an input for our architecture method. And here of course, let's say we have some other requirements, for example the electromagnetic regulatories or requirements, the EM, I think it's I requirements. And let's say we have some regulatory standards. Okay. As output we have the specified and reviewed requirements, similar to our method we have here. Of course we would also need a step description here, but let's save a little bit of time. And then here we have our EE architecture method. Here as output, of course, we have our EE architecture model. And then we can continue, because what comes after the architecture, of course, some specific development tasks, such as, for example, the CRT design method, or here when we speak of EE architectures, of course, we have the circuit diagram and all the calculations to make this right. So let's say we have here 3 different methods. We have the circuit diagram specification, and next to it we have the analysis. Circuit analysis. So here as input, for example, we have the architecture model, we have our predefined part list, and of course many other inputs we can specify here. As output we have our circuit diagram, which is of course one input for our analysis. Here of course here are much more inputs, especially parameters and many more, but let's keep this short. And then with that done, we can, for example, continue with our PCB design. Here as output, of course, we need the same circuit diagram, but in an analyzed way, so it's a next generation, it's another generation of this. So let's say this is Gen 0, and this is Gen 1 because it's analyzed and therefore also optimized. And this is an input for our PCB design. And we can also say, maybe let's undo this. We can also say we go here directly, and also we use this analyzed diagram as additional input. Here's a typo. And of course output is on one hand our PCB model, and for example some specific specs for the supplier. Let's call it supplier specs for supplier. Okay, this was now one path. Of course, other path, for example, are the mechanical design, when we, for example, develop a mechatronic system, or also the software part. And then it gets really interesting, because then we see also all the different interactions between them. And when we come to this step or to this level, it gets more and more important that we also specify here all the steps, because then we exactly know what is happening and what is done inside these methods and how this output is created. So in a bigger team, we better understand what is happening and what are the others doing. Yeah, that's it in principle. That's the memodya tool. Maybe just a few informations. Here on the left we have our modeling sidebar. Here we see all elements, we see also on the diagram, and for example we can also reuse different information. So for example, when we create a new method, oh, that was one. So and let's say we want to reuse this use case, we just have to drag and drop it here in the diagram. And when we want to allocate it to this method, we just drag and drop it here on the left side. Then it's recognized as input, and then it's assigned as an input. When we don't want this, just select the line between the input and the method and just delete it. And then just drag and drop it into the diagram again, and for example, you specify it as an output. Yeah. Then another thing here, of course, we have here two different modes. We have the edit mode and the non-edit mode. This is because it's sometimes really beneficial. For example, just if you want to review or want to consider this diagram and do not edit it, we can globally turn on and off the edit mode. So it's more simpler to just check what is part of the diagram, what is not here, and yeah, you can activate this edit mode from anywhere. And here's another nice feature. We have also this color mode. Maybe I click here on this method and you see it a little bit better. Then here these colors are available here, or in that case not. So here it's more focus on the diagram, or with the color mode it's also, I think it's a little bit better readability of the right sidebar. Yeah, that's it in principle. We also have here, for example, if you want to chat with your team members, because yeah, you can invite here all the team members and you can work on these diagrams collaboratively. It's really completely live, so you see exactly what the others are doing, and then it's also nice to have here a small chat where you can contact all your team colleagues. And yeah, that's in a short version our early access version of memodya. And at the moment here we have really the basics we need for the specification of the methods, and a lot of more features are coming soon.